So this video is just going to be a quick reminder on what we're doing with our first moment of area. So here's a kind of an example from the last video where we introduced the idea of our horizontal shear, and we're looking at basically shear along this bottom surface of our element. That's what the horizontal shear force that we've calculated. That's what we have there. So this is our element that we've cut through our beam, but now we're going to rotate this and look this way into the cross section of the beam, and here's what our element looks like from that direction, and that's our area A that we're integrating through. So our first moment of area, Q, is going to be equal to the integral of y dA across that area. But the way that we calculate that generally in practical terms is that we say, well, if we add up all the y values, and we add up all the area values, all those little elemental areas combine to make the total area, and if we multiply those by all the, each of those elemental areas by all the y values, that's the same as multiplying the average y position, let me just redraw that, by the total area. So this is the y centroid of this area here, and this is the total value of that area. The magnitude of it. So that's how we calculate it in practical terms. And we always calculate this, that y position is going to be relative to the neutral axis here. So what we find is, actually, so we're finding the horizontal shear at this surface here at the bottom of that. And if we take an area that's below, like the area below that, so at this same height, y1, but we're looking at the area below it, so we're still going to actually find the horizontal shear at this same surface. And what we'll find is that the first moment of area of this area is the same as the first moment of area of that area here. Because if we look at the first moment of area, for example, about the neutral axis, if we take the whole area, let me delete some of these lines, it's getting a little busy. If we take the first moment of area about that neutral axis and we take this whole area, everything above the axis is going to be positive, everything below the axis will be negative. So Q about our neutral axis is going to be 0, right? That's what we're going to find. So in this case as well, again, we've got to see some above the axis. If we take now this area here, some above the axis, some below, and those are going to, we're going to have some positive, some negative, and we should end up with the same value as if we took this area. So this surface, we're going to get the same value for our horizontal shear, whether we take the area above that surface or below that surface. Okay, so that's a helpful thing to know, and then we're going to dive in the next video. We're going to take a look at an example where we calculate this, where we have to calculate first moment of area.